All right, a couple more and we'll be done. So we're comparing exponential functions, and really what this is trying to get us to do is look at when x, well, we'll go -1, 0, 1, 2, 3. Why? Because I'm copying that from the book, to be honest. What I'm going to get in the function of g of x is, let's see, right, an exponential g. So here's my g of x, is a relationship when multiplied 1.5 for every 1 unit. Okay, so what that tells me is I have this parent function. And from the beginning, I'm told to work on an interval from 0 to +2. And that's going to be able to get me on 0 to 4. All right, so this right here is the point they're going to share at 0 and 4. But this new g of x is increasing at 1.5. So what that means is I'm going to look at it when it's -1, and I'm going to get 2.7. So at -1, I'm going to be at 2.7, somewhere around in here. So all of a sudden, I'm already off of my parent graph. Can't make that any bigger, it's just doing some weird thing. So then I'm going to increase by 1.5 again and find out that at 1, I'm over here somewhere at 6 here. So now I'm to the right of the graph, where on the first one I was at -1, 2.7. That's somewhere to the left of the graph. And actually I'd be closer to here. Why are you not letting me draw my point? There we go. So I was to the left of the graph when I was negative, but now I'm to the right of the graph. That's kind of weird. Okay, let's keep going. So when I'm at 2, I'm going to be at 9, because really all I'm doing is I had to take times 1.5 to get here, times 1.5 to get here, which means actually to go backwards, I had to divide by 1.5. That's how I got my 2.7. Now the last one I'm going to get is 13.5. And so at 3, well, that's right around here. I'm going to be at 13.5. So that's 14, about right here. Ooh, off to the right though. There we go. Boom, boom. About right there. A little off, but I'm still to the right. So we got this weird thing going on. We've got a parent function that we're comparing it to, or at least a function that we're comparing it to, that says it should be able to line up. And the only way to really get it to line up would be to do this. And what we find when we do that is we're actually increasing at a slower rate before x equals 0, and we're actually accelerating that. We're increasing at a faster rate when x is greater than 0. So that's our comparison. Both functions have the same value when x equals 0. That's right here, sorry. When x equals 0. So if, let me do this. I gotta move it up just that tiny bit to be able to show that. There we go. I'm still in alignment with all my points. I kind of messed up on the blue one before, but you get the idea. But the value of f is greater than the value of x, or value of g, over the rest of the interval. In other words, our black is actually, our original is actually greater at all times at the same values that are greater than 0 for g.